Today we will prove Green's theorem, that is third theorem, Green's theorem. So, what is this Green's theorem? It is nothing, it is basically extension of divergence theorem. So, it is extension of Gauss divergence theorem. So, we will prove this theorem by using Gauss divergence theorem. The difference between divergence theorem and Green's theorem is that it deals with the two variables. Let there are two variables, psi and phi. Psi and phi are the two variables for which we are applying the Gauss divergence theorem, and ultimately we will get the theorem which is called Green's theorem. So, we will use these two parameters, two variables. So, by definition, or the statement of the theorem is that double integral of psi del phi minus phi del psi, psi del phi minus phi del psi dot ds is equal to triple integral of, for surface it is for volume, triple integral of psi del square phi minus phi del square psi into dV. So, this is Green's theorem. So, here this whole equation or the expression is the variable in this theorem, and this variable, let this variable is any constant, any a. So, let psi del phi minus phi del psi taken as a vector. So, it will become double integral of a dot ds is equal to del square, means del dot a dv. So, it is same as Gauss divergence theorem. So, applying or using Gauss divergence theorem for a vector. So, what is this theorem? It is nothing, it is simple. A dot ds is equal to triple integral for whole volume into del dot a into dv. This is basically divergence theorem, where a is this expression consisting of two variables psi and phi. So, applying this means here a is this, putting the value of a here as well as here. So, we will get this theorem, that is Green's theorem. Here a, what is a? Here a is psi del phi minus phi del psi into ds, this is a, and is equal to triple integral of del dot again a. What is a? A is this psi del phi minus phi del psi into dv. Okay. So, I have put the value of a here, this expression, and or also value of a is here. Now, on the right hand side, it is del dot this function. Del means derivative. So, derivative of this function. So, we will apply the formula of derivative, that is product rule for derivative. So, we will get del means derivative or first derivative or differential operator. It will become del psi derivative of first, second as it is, and plus first as it is psi and derivative of second. So, del of del, that is del square phi. Okay. Now, for the first term, derivative of first term del psi into second term as it is del phi plus first as it is and derivative of second del of del phi, that is del square phi, and minus, yes not, minus again phi del phi into del psi, okay, minus is here, minus, and plus first as it is phi into del and into del, it will become del square psi into dv. This is ultimately we will get the equation this. Now, on simplification, it will become del psi del phi plus psi del square phi and minus del phi del psi and minus phi del square psi into dv. Now, this term is cancelled with this term because it is del psi del phi, it is del phi del psi, both are same, because in dot product there is no any difference between first and second term multiplication. So, del psi del phi means del psi del phi both are same, and minus it is plus, both will cancel out, and we will get finally v into psi del square phi minus phi del square psi into dv. So, this is the right hand side of Green's theorem and left hand side is same. So, it is nothing, we have put the value of a like this, that is expression, this expression is considered as a. So, on putting this value in Gauss divergence theorem, finally we will get the Green's theorem. So, this is nothing, it is Green's theorem. And left hand side is this double integral psi del phi minus phi del psi into ds. Okay. So, this is Green's theorem. So, this is all about the chapter of Coulomb's law, electric field and Gauss theorem. Now, we will start our next chapter or next topic, that is electric potential. So, you have already studied electric potential in 10+2 class. What is electric potential? Electric potential, it is V. So, what is V? You know that V is nothing, it is 1 upon 4 pi epsilon naught Q by R. So, this is the equation or expression for electric potential, and it is scalar quantity. You know that potential is a scalar quantity, it has no direction, and the corresponding articles, electric potential due to point charge, electric potential due to line charge, and equipotential surface, so on, these type of articles, these articles actually we have studied in the lower class. So, I will not solve these articles in this class, you will follow the same articles from the previous class or from this book or this chapter. So, this is electric potential. So, I will do only the article which you have not covered in the previous class, that is electric potential, due to quadrupole, because you have already studied electric potential due to point charge, electric potential due to dipole, but we have not studied electric potential due to quadrupole. So, quadrupole is nothing, it is consisting of two dipoles which are combined in nature, that is, as you know, this negative and positive charge, this is called dipole, but we are interested in quadrupole. What is quadrupole? it is plus charge, plus q1 charge, and minus 2 minus 2q charge, plus q minus 2q and again plus q. So, this is quadrupole because plus q and minus q, this is first dipole, and again minus q is lying here and plus q here, it is a second dipole. So, both dipoles are placed in collinear manner and the negative charges are combined at center. So, this is linear quadrupole. So, we will find the electric potential due to this linear quadrupole. So, this is important article, and this article has not been studied in the lower classes. So, I will solve the electric potential due to this quadrupole in our next lecture. Thank you very much.